what up? Thanks for coming. Glad to be here. Love Seattle. I used to live here in the past, and now I'm just back chilling. And yeah, this talk I think is going to be good because it has alliteration in the title, so let's get into it. So before we get started, let's do some introductions. Whoville, just like Grinch Who Stole Christmas. Hey, I'm Aaron Turner. I go by Torch2424 on the internet. I made that name when I was 6, and I'm on Twitter and GitHub. And I'll be getting into these in more detail later, but just some quick things. I'm a member of the AssemblyScript team, which is a TypeScript-like language to WebAssembly, WasmBoy, which is a Game Boy emulation library written in AssemblyScript for WebAssembly, Vaporboy, which is a progressive web app or PWA for WasmBoy, Wasm by example, which is kind of like Go by example of bite-sized examples for learning WebAssembly and getting into concepts. And I work at Wasmer in developer relations with a bit of like production JavaScript sprinkled in. So what are we talking about? Let's get into the agenda. Today we're talking about budgets. What kind of budgets? We'll be talking about the budgets of our users, such as financial budgets. We'll be talking about resource budgets, so like what kind of things can we accomplish on our devices, like considering CPU and things. And then we'll be talking about performance budgets, in terms of like measuring how fast or slow our app is running and how we want to allow our software to be. And then we'll be talking about building for these types of budgets, like what tools and technologies can we use to help achieve these budgets, such as WebAssembly. It's relatively new, shortened as WASM. It's a portable binary format that runs on the web in both the browser or your server. Then we'll be talking about Web Workers, which is pretty much a TLDR of threads on the web. And then we'll be talking about service workers and PWA, but in our context, mostly about how we can use them to enable an offline web. But first, I want to talk about people. And to start things off, I want to talk about the next billion users, or NBU for short. The next billion users are commonly known as the people who will be coming online in the near future. By becoming online, this could be either through a smartphone, a lower-powered laptop, or et cetera. And it may or may not be their first experience with technology. And it's a really hot topic. We have Google talking about it. We got Facebook planning about it. We got Microsoft researching it. We got books on Amazon about it. And we got TechCrunch asking questions about it. And as you can see, this is an actual hot topic. But but let's dive a bit deeper into one of those resources and see what they have to say. I will be showing quotes here, but I'll summarize them for in case you can't read them or it's too far, however it may be. But this is a quote I pulled from the first Google article. And the quote explains that NBU users have a mobile-only mindset, meaning their access to the internet kind of revolves around only their mobile device. They also talk about ubiquity, which is where your apps are available in multiple places, and both on the device itself or depending on the location you may be in. And they want their software localized to them. The article mostly talks about language, but I'll explain how I feel like this applies to performance as well. And another quote I pulled from the same Google article mentioned where these NBU users are located. If you look more into NBU, the conversation focuses on areas like Brazil, China, India, and Nigeria. And these 100% are great areas to focus on. They definitely experience these problems. But what if I told you that NBU users don't only exist overseas, and I'd even argue they exist in tech hubs like Seattle and Silicon Valley? I want to talk about poverty in the United States of America. But poverty is a very strong term. What are we talking about here? Well, if we Google for the definition of poverty, we get this. And what I'd like to highlight here is that poverty is the condition of a person who lacks the financial resources for a minimum standard of living. So let's use a poverty line as our base for financial resources. According to the US Department of Health and Human Services, in 2015, for a family of 4, if you made less than $24,250 US annually, you are in poverty. But how many people is that? That's going to be 43.1 million people in the United States of America, which is 13.5% of all people living in the United States of America live in poverty. And if we take a look at California, which probably has one of the largest tech hubs in the world, Silicon Valley, it's going to be 6.25 million people living in California, which is 16.5% of all people living in California that are living in poverty. But why do I care about poverty? Because I was honestly one of the people living in it. After I went to college, I learned and understood more about my family finances from student financial aid applications. And in 2015, my family made $11,205 US. And we were a family of 7 in a 2-bedroom apartment. So if you take a look at the numbers, that's very well below the poverty line. So going back to these 3 points, having a mobile-only mindset, revolving your software access around mobile, ubiquity, having it everywhere, and localization, I heavily relate to the NBU story, if I was not one already. And people in poverty experience the exact same problems with the web, and I think there is a greater community here to be talking about when it comes to these issues. So I'd like to share some of my early experiences with the web. I first got online when I was 6. I'm definitely younger, and I experienced more of the tail end of the early web, I would like to say. I've heard plenty of dial tones. And I got my internet access from free America Online trial CDs, and what I would do is just cancel my account before the month ended and get a new one. That way I had internet access at home. And my mom couldn't afford a good PC, but it was around the same time where you kind of needed a PC to get things done. So what we had was a Windows 95 machine, but in 2003. This wasn't my first computer, but it looked equally disgusting, so yeah. My first major experiences with the web were 2 web games, Disney's Virtual Magic Kingdom and RuneScape. And they were both very community-oriented games that I would play with my friends, RuneScape being an MMO, massively multiplayer online game. And I very distinctly remember, my computer could not handle Disney's Virtual Magic Kingdom. Like, if you load the game, it would just stay loading forever. So I had to play at a friend's house. So for me, this game was not ubiquitous. I could not run it on all my devices, only the ones that I had limited access to. And my computer could barely run RuneScape. Like, if I let it load for 15 minutes, I could use a chat box, but I couldn't actually play the game. And again, I never invested time or money into this game because I could only play it on the higher-end devices I had limited access to. And the price of RuneScape was only $5 a month. All my friends were members of RuneScape, and I was not. And my family could afford the $5 a month, but it's just we could not afford a new computer that had an upfront cost for me to get the full value out of being a paying member of this game. So what's the lesson here? Should we be building our web apps for Windows 95 Internet Explorer? No, that's not the lesson. But the lesson is that we really want to make our website or application ubiquitous, because the fact of whether your application or device supports a number of devices per resources or platform can really affect whether you get users in general, whether they upgrade to a paid tier, or they buy your product, whatever it may be. So next, I want to talk about some of my other web-enabled devices. My first smartphone I got when I was about 14, and then the best cheap phone I could buy was the LG Optimus V for about $150 US. And Virgin Mobile had the best prepaid data plan for the price at the time. So my natural instinct was, well, if I search for cheap phones, the price range is now about like $300. These phones cost more. But a renewed Samsung Galaxy S7, which is 1% of all mobile US devices and much more in other countries, it's still this price range. It's very relevant. And the only other device I owned for accessing the web was my cheap netbook. And my mom saved up for about a year to buy me one for $300 US for my birthday. I needed it for school and used it for general computer stuff. But when you have a netbook, what you like to do is play League of Legends at 12 frames per second, because that's just what you do. But my home internet was never a given for me. Depending on whether my family could afford it or not, I'd have home internet access. So I had to hotspot my phone against the mobile phone plan's terms to become my home internet. So my data plan became both my mobile and my home internet that I would share on my phone and netbook for the entire month. And in fact, this is when I said I seriously started developing. I was really into rooting Android phones, and I started playing with Linux so I could run scripts to modify ROM images of Android, whatever, and decompile APK files. I had to learn how to code on my phone's hotspot. So when you want to conserve data because you're downloading Linux on your mobile data plan, or you run out for the month, you become extremely reliant on free Wi-Fi hotspots. So for real, I would literally just go to McDonald's to download development stuff, apps, music, games, even read news, because news websites are kind of heavy if you're opening up like 20 in a different tab, etc. So I became heavily reliant on my phone for both its the phone itself and its data plan. So what's the lesson here? Should we be testing prod on McDonald's free Wi-Fi? That's actually maybe a good idea. Design your application with a mobile-only experience, whether it be making it responsive, reducing your bundle sizes so your users aren't encouraged to wait until they have access to the internet and they can use it wherever they want, where they have their data, or even making a completely different version of your product hyper-optimized for mobile. It can definitely help your users immensely and encourage them to use your application when they want to, not when they can. But I really don't want to talk about myself all day. I really want to focus on other people, actually, and ways I've seen them experience the web. And the most notable story I have about this is probably about Obama. I want to talk about Obama phones. Obama phones are kind of a slang term for a free government cell phone and a free government phone plan. The program wasn't started by Obama, but it rapidly expanded during their term. And the program is formally known as the Lifeline Assistance Program. So let's take a look at what the plan provides. You get, this is one of the many providers for the program. You get a free phone, minutes for talking and texting, and we get 1 whole gigabyte of data. And if you're using your phone hotspot as your home internet and your mobile internet, which my whole family did at some point because you didn't have home internet access, you get to watch 1 hour of Netflix for the entire month, either on the go or at home. So let's take a look at how popular these devices actually are. Well, Wasmer, my company, is based in San Francisco out of the Tenderloin district, which you can kind of say is the low-income district. And here's a tent. And I see these out in Los Angeles as well, and people are lined up to join the program. Let's take a look at the performance of these type of devices compared to higher-end devices that a lot of us here have. This is a slide from Christopher Baxter's and Malte Ubel's JSConf US 2018 talk. It shows the Nokia 2 at the bottom there, which is popular in the MBU overseas markets, but it has very similar performance to a lot of these Obama phones. And it's just getting completely wrecked in single-core performance compared to your iPhone 10, which is most web apps because JS is running the main thread and how that kind of works. But let's expand on this. What about the performance of devices I've shown so far? So let's take another look at that Samsung Galaxy S7, which is, again, 1% of all US mobile devices, according to Device Atlas. The S7 is 0.63 the performance of a Pixel 3, 0.6 of an iPhone 10, and 0.38 of an iPhone 11. Even the Samsung Galaxy S8, which is the purple bar right above, and it's going to be 2.9% of all US mobile devices, is just getting decimated in pure performance. So now we're talking about 4% of like devices that people are actually using that are just getting decimated by the devices we probably used for development. And next, let's take a look at these Obama phones that I was mentioning. Let's see what type of devices we can get from the program. Well, let's say we can want to splurge a little bit, and instead of getting our free phone, we scroll down and choose one for $130 US dollars. Let's pick the Moto E5 Play. I dare to say if you have an Obama phone, it's probably a miracle that you even use the web. If you splurge, pay for a device, you're getting 1/10 of the performance of an iPhone 11. So please try to imagine what it must be like to use something that already bothers you on the web, but then 10 times worse of that. And this is why performance budgets are important. It automates away the process of having to guess about like how performing your app is for these audiences that you may not be directly connected with. You should still definitely be testing on these low-end devices yourself and experiencing it for yourself, but it can be a reality check, especially in CI pipelines, to help improve your performance for audience you don't have access to. And if possible, set these up as soon as possible, either day one or sooner the better. That way you're aware of what's going on here. And one more story, Max Bittaker is an awesome friend of mine, and they made a WebAssembly sand game called Sandspiel. They found some quick performance wins in their app from using WebAssembly and kind of messing around with some of their flags. But they didn't have a performance budget. So what they did instead was build new features on top of that. They ended up scaling the way things are saved into the database. So now these maps and things that are saved expect a different level of performance. So when he tried it on a lower-end phone, he realized, oh, I messed up. Now people with lower-end devices can't play this. You can only play it on an iPhone or like a MacBook Pro. And because of this, he can't undo it. And the point here is that, just because you find these new headrooms from performance budgets and things doesn't always mean you can invest them back into new features. You definitely want to be aware of these lower-end audiences and make sure your features that you're releasing still cater to them. So what's the point? Should we test on Obama phones? Yes, that's actually a good point. We need to localize our applications for certain communities. We should reach out to these communities and learn their terms like Obama phones, and make sure our apps work for their unique characteristics, whether it be language differences, like the article mentioned, or ridiculously slow CPUs, like I'm mentioning here. And even the digital divide, where tech was too expensive for a lot of people before, so they had no access, so they're just now learning new terms like refreshing and things like that. So let's take a look here. We can see there are 3 major problems: ubiquity, having a mobile-only mindset and just how you work, and localization. This is common in overseas NBU, but also low income. There is a greater community that experiences these issues. But how can we solve them? Well, there are technologies that run in all major browsers today that we can use. And let's take a look at my personal favorite, WebAssembly. So WebAssembly is a universal low-level bytecode on the web. Because of this, WebAssembly is great for running logic-heavy tasks, such as image manipulation, physics for games, or heavy math computations. But why is it great for this? This is because WebAssembly offers predictable performance. JavaScript needs to be parsed, evaluated, and then compiled many times through a just-in-time compiler, and it starts to optimize these hot functions to make assumptions about them so it can run a lot faster during its interpretation process. Well, bytecode is compiled from the beginning, and it offers a more consistently predictable performance because a lot of these runtimes will just run the code straight through. Therefore, there is no fast path to fall off of, and it always runs consistently fast, depending on the right use case. WASM in its current state, currently does this, and it's awesome, and it's great to try it out. It's not just straight faster than JavaScript, but it offers predictable performance, which you can look into. And one more thing, WebAssembly is extremely portable. We have WASM running on both the browser and the server, so you can share code between your browser, server, or even many more platforms. It can be run using Node, like as in use the WebAssembly object there, or even bundle packages to NPM to be used both in the browser and Node, or you can use WASI, which is the WebAssembly system interface, to run applications on your system in a runtime like Wasmer, which is where I work, and you can bundle your WASI applications up to WAPM, which is the WebAssembly package manager, and you can even embed the runtime into your Python server and then use the runtime there. So you can pretty much run your WebAssembly like a lot of different places. And this is really good for your budget as the developer, because now you can write it once, like your business logic and things, and use it in multiple places. Google Earth gave a great WASM SF talk, or WebAssembly SF. There's a meetup out there. And they use WebAssembly to make their code more portable across the web and many other applications and systems at Google. So WebAssembly sounds really cool. How do we get a running start? There's WASM by example, which is made by me. Again, it's essentially like Go by example, bite-sized, copy-pastable tutorials and examples. There's even a language drop down at the top, so you can choose what language you want to learn from, even like reading languages. There's someone helping me translate it in Spanish currently, and it helps you really learn the concepts of WebAssembly from like the low level up to like building production things. And there's a lot of languages outputting WASM, as in like the language you can choose. And the most mature three are AssemblyScript, which is a TypeScript-like language to WebAssembly. I'm on the team there, I help out a lot. And by TypeScript-like, I'm meaning that you can't just take your TypeScript React app and compile that down to WebAssembly. WebAssembly doesn't have access to the DOM and things like that, so you're not gonna be doing things like that, but it has the exact or very similar developer experience as writing TypeScript. You still have a TS config and a VS Code to be able to detect all the types and things. And there's already some pretty good tooling for it. Joshua Tenner wrote a library called Aspect, which is great for testing. Another language is Rust, which probably has the best tooling right now and is very mature. It has really good support for binding and passing objects between both WebAssembly and the JavaScript. And then Scripting is a toolchain for C, super mature, evolved from Asm.js, which is a superset of JavaScript meant for performance. And what it does is turn C and C++ into WebAssembly. So next, let's talk about web workers. Web workers, like I said, is like threads in the web, which is great for parallelization and things. And Performance Matters is a great talk by Emery Berger. I would highly suggest watching the talks for full context, but essentially, Moore's law is slowing down. Because of this, we can't remove heat from a single core on the CPU anymore fast enough to keep increasing our clock speeds. Thus, we had to start making CPUs with multiple cores, because that's how if you can't dissipate the heat from one core, you need to put multiple on the CPU. But a lot of apps don't take advantage of this. And this isn't a problem unique to the web. It's a problem with computing in general that we're currently facing. So we start to see this idea of a UI, or a main thread. This is where user interaction should happen. Business logic and computation can be moved to a separate thread. That way the UI thread is able to be smooth and feel good to the user at all times. And my friend Surma is working on a lot of resources to help this idea of going off the main thread for the web. Surma has been writing a lot of interesting blog posts on the topic, and I definitely recommend the read on some of the problems they've seen and how we can fix them. And they even built this thing called Comlink, which is a wrapper around the web worker API that provides a much cleaner API to make things easier. It makes isolating logic currently on the main thread and moving it over to a web worker. This even allows passing callbacks and functions into the worker, which is extremely hard to do without this library. And it's great for getting started with web workers. I highly recommend it. And the last technology I want to talk about is service workers, but I really want to talk to them more broadly as progressive web apps as well. What a service worker is essentially a client-side proxy. In other words, whenever your website makes a request, the service worker can capture that request and return a cached version or do something special with that request. But this is interesting for us because it enables offline access. This is huge for people who want to conserve data or who run out of their data plan or don't even have a data plan and only use Wi-Fi hotspots to access their internet. And it's also really handy for plane rides in tunnels. A variety of tools for service workers and PWAs. Workbox is a tool for generating service workers. Lots of good docs and visuals to explain what's going on kind of with all these requests capturing. And there's framework tooling now that will PWA by default, such as Preact CLI and Create React App. Framework tools may be a great way to get your feet wet without having to commit to it in your production application today. So I'd highly recommend checking out your favorite frameworks tooling and see what they do. And let's highlight some good progressive web apps you can play with today. WebAssembly.sh is made by Wasmer. It's open source, and I worked on it. It's a shell that runs in your browsers, and it runs all these commands using WASI, but using a JS polyfill to stub out things like file system. And here's a GIF of showing QuickJS, which is a JavaScript engine, running in WebAssembly. And it's kind of funny, because now you can run like JavaScript on the browser, which is like, what are you doing? But it's really great. It has a good use case for sandboxing JavaScript. So if you have untrusted JavaScript that you want to run, you're now running it in a separate runtime inside the browser, which is really interesting. It uses comlinks and web workers for piping processes, standard input and output between each other, and works offline by using a service worker from Preact CLI. Next, I want to talk about Vaporboy, which is an open source PWA side project of mine. It's powered by WasmBoy, that Game Boy emulation library written in AssemblyScript that compiles down to WASM. And then what it does is that it takes that WebAssembly core that runs all the actual heavy logic of computation into a web worker. That way, all that heavy logic is able to run on a web worker. The UI thread, all the buttons feel really smooth, but then all the data gets passed back to the main thread, which is then just shown to the user. It works offline as well because it uses Preact CLI, so a lot of quick wins there. And the last one PWA I want to talk about is built by Julian Poirot, a very close friend of mine, and it's open source, called RecipeSage. It has a custom-built service worker in Workbox, so it works offline, and it's great for grocery stores that have like terrible connection. So that was a lot of information, but let's wrap things up. Here are my main points. Budgets exist everywhere, not just overseas. Whether it be overseas itself, low-income, rural areas, they exist everywhere, and we should really be conscious of them. Create performance budgets. It really gives reality checks about your app and helps you kind of learn about these audiences while you're building for them. And then also use WebAssembly, web workers, and service workers. They have a right time and place to use them, and you definitely should. They help you build for these budgets. And now that I've given you the keys to the kingdom, this new headroom does not necessarily mean you can fit in a bunch of new performance hogging features. You definitely still want to be aware that this isn't going to change everything. But yeah. And here are some major resources that I've shown. For WebAssembly, there's WASM by example, that go by example, bite-sized examples. And also, if your language compiles down to WebAssembly, which honestly it probably does, as long as it has types, there's probably documentation on how to compile down to WebAssembly, which is really nice. For web workers, there's Comlink, which is that library I mentioned for passing data between web workers really well. And there's also Surma's blog post, which has a great information about the problem itself and how to work for it. And then there's also service workers, which has Workbox, which has an API for building new service workers really easily and doing all those request capturing. And also your favorite frameworks CLI tool probably has some support for service workers you can definitely look into. I want to give a quick shout out to some people, the reviewers, Marcy and Brendan, thank you very much for looking at my slides. Just friends and family, assembly script. Currently the project is still young. We're looking for sponsors. If you try it out, it's very TypeScript-like. Maybe you like TypeScript, you want to try it out. There's an open collective, you can definitely contribute there. Or if you want to help with the project itself, we're still looking for contributors and the team is still growing. Definitely the WebAssembly community itself. The Rust WASM team is a great resource to reach out to, and definitely you can get involved there. The WASI working group, WebAssembly is SF. If you're ever in the San Francisco area, I highly recommend coming by this meetup. And then WASMer, they helped out a ton here with looking at my slides as well. And then Surma for all the web workers content, Max Bittaker for letting me share their story, and then my family, like my partner and my mom and my dad. So yeah, thank you very much to the conference organizers for having me. Thank you for sitting here and watching me. And please reach out to me over Twitter or here at the conference. I'll be around. I promise you can find me. Let's continue this discussion. I'd love to keep talking about it. And thank you very much. Enjoy the conference. Yeah.